Hey guys, Paradoxio here. Welcome back to a brand new programming tutorial, everyone. Today we are going to be going over object-oriented programming in Python. Now, object-oriented programming, which is sometimes abbreviated as OOP, is a core concept and structure in programming that is very important, and we should all learn it in order to advance further in our programming career. Now, object-oriented programming is a programming paradigm that organizes code into reusable and interrelated objects, making it easier to manage and scale. To get started with object-oriented programming, we need to create something called a class. Now, a class is essentially a blueprint or floor plan for creating objects. It has its own properties, or sometimes called attributes, and methods, which are sometimes called behaviors. And these are all unique from object to object. For an example, we can create a class called dog. And inside dog, we have several different attributes. This could be the dog's breed, the dog's name, the dog's age, the dog's weight, the dog's color of their fur, etc. Now, whenever we are talking about attributes or properties, we have two types. We have a class attribute and an instance attribute. First, let's go over a class attribute. Now, a class attribute is an attribute that is shared among all objects. So, what is something that is shared among all dogs? Well, we have species. And all dogs are of canine species. So this is an attribute that is going to be shared among all dog objects. So, this is a class attribute, and it's shared among all dog objects. Now, the next thing we have is a constructor. And we create a constructor by typing in def dunder init dunder, and then we pass in self and all the little attributes that we want our dog to have. For an example, like I said before, dogs have a breed, and they also may have a name. You may type hints these if you want. So name can be a string, and breed can also be a string. Let's also add an age, just for good measure, and we can make this an integer. Now, whenever we are creating a constructor, we need to define all these through self. So we need to type in self.breed is equal to breed, self.name is equal to name, and self.age is equal to age. Now, we have something else called a method. And for an example, for a dog, we can call this bark. And we can print wolf into the output whenever we want to make our dog bark. We can also create another method, and this one's going to be a little bit more interesting. Sorry, guys. Almost said introduce and interesting at the same time, but that's all right. Let's create a method called introduce self. We can print an F string here, and we can say bark, hello, my name is self.name, and I am a self.age, year old, self.breed. Now, there's a lot of moving components here, so let's talk about them. So, again, we have our class dog, we have a class attribute, which is going to be shared among all dogs, and this is called canine, because dogs are a canine species. We have a constructor here, which I'm going to create a comment, constructor method, and this is going to allow us to choose all of our attributes, so our breed, name, and age. Then we have two methods called bark and introduce self. Now, here's something we should probably notice about these methods. They have an argument called self. What is self? Well, self is referring to its own instance, which is created here through the dunder-init method, or known as the constructor method. And we use self to access our breed, name, and age of our dog object. If I didn't use self, for an example, I can leave self out right here and remove it in our string. And what I can do is I can go ahead and create dog. We can type in dog1 and set it equal to dog. And we can go ahead and give it a breed. Let's make him a dachshund. And we can give it a name, Max, and an age. Let's say our dachshund is 5 years old. Well, to make it introduce itself, I can type in dog1.bark. But whenever I make it bark, we get wolf because we have self in there. If I go ahead and remove self, we get a type error, and it's basically saying that the bark method of our dog class takes 0 positional arguments, but 1 was given. Well, why is that happening? Well, automatically for every class is inserting self as an argument into each method. So to make our methods properly work, we must include self. And now we get wolf in the output. Well, what if I change bark to introduce self? Well, we're gonna get that same issue as you can see right here. Well, let's go ahead and provide self inside the parameters of that method. And let's go ahead and run our code again. And now we get a new error called name error. And basically it is telling us that name, this variable here, is not defined. And our IDE is actually telling me that. Now, why is that? Well, remember, it all goes down to the scope. Inside this method, there is no name. We can make the name like name is equal to whatever, and it'll work that way, but we aren't pulling the actual name of our instance. To do that, we need to type in self.name, and we must do this for all variables that we want to access from our instance. And remember, self is referring to the instance itself, hence the name self. And that's how we're able to access our instance's name, age, and breed attributes. Now, when I go ahead and type in dog1.introduceSelf in line 17, we now see bark, hello, my name is Max, and I am a 5-year-old dachshund. So great, we created a dog object that is a dachshund breed. His name is Max and he's 5 years old. Well, I want to create another dog. I want to have 2 dogs. So we can make dog2, set it equal to dog. And we can make this one a poodle. And we can give it the name, what's another dog's name? Screw, let's just call him Max 2. Sorry guys, I'm not a dog person, but we have a different name. And we made this one 2 years old, so still a puppy. Well, now I can come down here and type in dog2.introduceSelf. Now, remember, there's only one dog class, but I'm giving it different attributes. So we have 2 dogs here, and these are called instances. Now when I go ahead and run this code, we have bark, hello, my name is Max, and I am a 5-year-old dachshund. And then on our second line, we have bark, hello, my name is Max 2, and I am a 2-year-old poodle. So we have one class, but 2 instances, and both of these instances are referring to the same class, but they have their own unique attributes. They have their unique characteristics. This is very important. And this is what I meant by a class being a blueprint for creating objects. And this is also what I meant by making it easier to manage and scale, and how classes organize our code into reusable and interrelated objects. But instead of introduce self, what if I type in print dog1 dot species? And in the next line, I type in print dog2 dot species. Well, we're going to get K9 for both of them. And that's because, remember, species is a class attribute and is shared among all dog objects. So no matter how different the instance attributes, which are these here, are among all of our dog objects, they are all going to have the species attributes set to K9 because they are all species. They're all K9 species. And for this context, we use K9 or the species attributes because that's what dogs are. So the main takeaway from this is the difference between instance attributes, which I'm going to create a comment here. The main takeaway is the difference between class attributes and instance attributes. Class attributes being the same among all objects and instances being different among all objects. I also want to talk to you about the constructor method, which allows us to construct our instance, which is giving our dog class our breed, our name, and our age. Also want to talk about the methods, which are these two. And these are our behaviors that I was talking about earlier, such as bark, which is a behavior or a thing that a dog does. A dog barks. Now we have introduce self, which just basically introduces each instance by giving it their name, age, and their breed. And that is the bare basics of a class, but there is more to talk about. Let's say we want to change our instance's attributes over time. Well, let's say we have a class called bank account. And we can go ahead and create a constructor. And we can type in balance, which is going to be a float or a decimal point number. And we can type in self.balance is equal to balance. And then we're going to have two methods. And this is going to be deposit and withdrawal. Now, we want to change this attribute. Now, before I do that, let's go ahead and create a bank instance. So bank is equal to bank account. And for balance, I want to do $100. Whoops. Don't know what I'm doing there. Well, I can change the bank's balance by typing in bank.balance is equal to $150. And then I can print bank balance, and we'll get an output of 150. And there we go. We have 150 in our output. But we set it to be 100 up here. Well, on line 14, we are simply just reassigning the balance attribute to be 150 for our bank instance. Well, we can also do this in our methods. In our deposit method, we want to deposit more money into our account. So we'll just type in self.balance plus equals amount. And for withdrawal, we want to take out money. So we want to type in self.balance minus equals amount. And now, if I type in print bank.balance, we will still have $100. But in between lines 12 and 16, I can type in bank.deposit. And then in here is going to be the amount I want to deposit So let's do $25.75. And if I go ahead and run this code, we now get $125.75 in our output. But let's say later I want to withdraw some money. We can type in bank.withdrawal, and we can do $75.68. So $75.68. Well, now we have $50.07 if we round it correctly. So that's how we can change the attributes outside and inside methods. But let's make this a little bit better. Let's say we don't want to be able to go negative whenever we are withdrawing. So we could type in if amount is greater than self.balance. We can raise a value error, and we can type in cannot withdraw more than what is in your balance. And after that, we can just type in self.balance minus equals amount. So now down here, I could type in bank.withdraw, and remember I have $100 by default. So if I try to withdraw 200, we get a value error saying we cannot withdraw more than what is in your balance. And that is coming from line 11 right here in this check. But if I type in 50, we see that we have 50 in the outputs because we have taken half of our money out of our bank. Let's talk about inheritance. Speaking of money, let's talk about inheritance. Alright, inheritance in programming refers to classes taking after one another. Let's say we have a class called animal. And in here we have a method called speak. I'm going to pass in self because we need to, and we can print I have spoken, like that. And then we can create another class called dog again. But this time we're going to write a set of parentheses after dog, and we're going to pass in animal, which is referring to this class right here. Now, what we had just did was we create a class called animal, and we create another class called dog, but we have written our dog class to take after the animal class and inherit all of animal class's things, such as its attributes and its methods. So even though I have written nothing inside of this dog class, if I go ahead and create a dog called dog1 again, and set it equal to dog, and then I type in dog1.speak, we will still get I have spoken in the outputs because it is inheriting this method naturally. Now, what we can do is override this, and this is called polymorphism. We can type in def speak, self, and then we can print wolf, wolf. Just like that. And if I go ahead and run this code, we now get wolf wolf in the output because we have overridden this function with this one, and that is polymorphism. To better visualize this, let's create another class called a cat. And inside the speak function, we're going to make it meow. And let's create another instance of that animal, which is a cat. And now we can type in for animal in dog1, cat1, animal.speak, run our code, and we get wolf wolf meow meow. So, we have successfully overridden this speak method from animal with a speak method in each of our respective classes. But if we had left nothing here, just like that, and we try to run our code, we're going to get I have spoken, I have spoken. Now, this works the same with attributes. So, if I create a init method up here, or our constructor method, I come down here and try to print animal.name, we get hello printed out 2 times. Let's actually change that to max. I don't know why I've written hello there. Whoops. But we get max and max printed out both times. But if I come down here, add in these constructors, and if I actually just remove that, so that way we can choose them. Let's do Sally for the dog, and Andy for the cat. And now we have Sally and Andy. So we have just also overridden a default name. So that's pretty neat. That, my friends, is polymorphism. Let's talk about abstraction. Now, abstraction is done a little bit differently in Python than other programming languages. To utilize abstraction, we actually have to import it from another module. So from ABC, which stands for Abstract Base Class, we're going to import ABC in uppercase and abstract method down here. So now what we can do is we can create a class called animal again. And to create an abstract method, we can just use the @ decorator here, which is the @ symbol, and then type in abstract method. And we can create our method, call it speak again. And then down here we can write pass. And down here we can type in class bird, which is going to be deriving the class animal. And we can type in def speak, and then we can print chirp, chirp. And then we can type in bird1 is equal to bird. And I keep hitting the wrong key. And then we can type in bird1.speak. And we get chirp chirp in the output. But what's the difference between abstraction and just simple polymorphism? Well, abstraction, at the very, very basic differences, is that we cannot create an initialization or an instance of this animal class. So I can't just type in animal is equal to animal like that. That will not work. Now, in just plain polymorphism, that would work, but with this abstract method decorator here, we cannot create an instance of this class. We are using it because it is a base class, essentially like a blueprint. It also enforces the implementation in subclasses, which are these things here. Bird. Bird is a subclass of animal. It also catches design flaws early at compile time whenever we run our code, and it ensures consistency in subclass behavior. Now, this just allows us to write our code more efficiently, and it allows for less errors to be made in our development. I highly recommend that you use abstraction anytime and anywhere that you are able to. Lastly, the thing I want to talk about is public and private properties. Now, remember, properties and attributes are used in a similar context. We can mean the same thing when we say property or attribute. So, let's say we have a class called person, and I have a constructor method here, and an attribute called name. Whoops. And let me fix that. There we go. I can simply just type in person is equal to person, give it the name Alice, and print person.name. And then we get Alice. But I can also type in person.name is equal to Bob. And then if I print person.name again, we will see Alice and Bob printed. We can create a private property with a getter and setter. And we can do this by typing in a double or single underscore right here under our self. And this just basically makes it a lot more stricter in what we can do with this property. So now, if I try to run this same code again, we have an attribute error. We can't do anything with it. But if I just do that, or well, if I do that here as well, we still can't do anything. We cannot change it. Well, this is how we can go ahead and change it despite that this is a private property using getters and setters. First, let's create a property by using the property decorator. And we're going to call this just name. I'm going to make it self. And we're going to return self.name. But wait a minute, I tried using the _name outside of the class, but it gave us an attributes error. Well, see, private properties are not allowed to be used outside of that class. They are only allowed to be used within that class. So, if I use it like this and I run the code, I will get no errors. But if I use it the way I did beforehand, we will get an error like you had just seen, an attributes error. But what if I want to set it to a different name? Well, I can type in @name.setter def name self value and we can just type in self._name is equal to value. And now we can come down here, create a person. And now we have changed the name to Bob. But what difference does it make if I didn't even have this property @decorator and this setter here? Well, there's not much of a difference at all if you don't care about validating what kind of value you were passing in to set your attribute to. See, I could freely just set person.name to be 3, and I would get 3 in the output, but that's not a name, that's a number. So what we can do is, inside this setter here, we can type in something like if not is instance value string. We can raise a value error and say that the name must be a string data type. So now with this line 15 here, if I try and run this code, we get a value error. So we use setters to sort of help us validate what kind of data or value we are setting that attribute to. And it just gives us a tiny bit of a security layer to our class's instance attributes. Now we also have something called a deleter. And we can make one by typing in @name.deleter. Name self, and we can type in self dot under name is equal to none, and this is just removing that value. So now if I type in person is equal to person Alice, and then I were to type in del person dot name, then what's gonna happen is if I try to print person.name afterwards, we get none in the output. And let me actually run this again in a cleaner terminal, none. But if I comment this name out and I run again, I will get Alice in the output. So we have a getter, a setter, and a deleter. And this is all working through private properties. So for every property that you make private up here, we should make a public property using this syntax right here. This is very good for validation if we want to be careful with what values we assign to specific attributes within our class. That's about it for the bare basics of object-oriented programming. If you've enjoyed this video and found it informative, be sure to subscribe to my channel and join my Discord server as well. We are trying to reach 1,000 members. I think we are about 50 away. Also, leave a comment as well, and subscribe to my second channel where I do Minecraft Let's Plays on. That is Paradoxial 2.0. I will have the link to that in the description. So if you're interested, be sure to check that channel out as well. But other than that, again, thank you guys so much for watching, and I will see you all next time with another programming tutorial. Bye-bye, guys.